Baroreceptors are going to respond to pressure, and osmoreceptors are going to respond basically to water content. Now, with respect to the last one, remember osmoreceptors really can't sense the amount of water. If you remember that particular example with the beaker that was filled with salt, and as we let it sit, the water level went down, but the salt concentration
Went up.
Decrease in H2O is synonymous with an increase in sodium. And it is the increase in sodium that is the stimulus for osmoreceptors. We've done that before, we're going to do it again, both with acid-base, and we're going to do it with urinary. So that is a key concept that you need to keep in mind. Different chemicals. For example, if you have a lot of acid that you are ingesting, a lot of protein that you're ingesting, you're going to see that there are receptors that are going to respond to it. Chemo. Let me simply write the word protein here, and then the word acid. For example, protein, to give you a hard and fast example of this. We're talking about some things such as a real high protein meal. The stomach is the first time that you have anything that's going to work on protein. The oral cavity doesn't, for example. So at that particular point, when protein is introduced into the stomach, those chemoreceptors are going to respond by producing material that can break down protein. Baroreceptors, well, that should be more or less obvious, maybe not. You go to McDonald's and you have two, what do they call them there? Whoppers? No, Big Macs, well anyway, you know what I'm talking about. Double order of French fries and a couple of milkshakes and whatever. What's going to happen to the stomach? It's going to become permanently enlarged. It's going to become distended. There's going to be pressure put on the wall of the stomach because of the great volume of food. And that particular pressure that's put on the wall is going to stimulate baroreceptors. So I just want you to understand that these particular three types of receptors are going to play a role in control of what kind of activity you have in the GI tract. You have two different reflexes. You see the short reflexes and you see the long ones. With respect to the short, the main thing here is no CNS involvement. And I believe that's written on that particular page too. But the central nervous system is not aware of what's going on. If you eat a normal amount of food in a normal amount of time, the GI tract just does its thing. You're never aware of it. You're not aware of things moving in the stomach or turning in the stomach. As it gets into the intestine, it's not going to give you any signals. Again, this particular short reflex are going to act at the level of the stomach. You see the expression gut brain. And I don't know why I'm doing this because I think I have a picture coming up right after this. If this is a picture of the gut, you have those layers of muscle. Remember intercircular and outer longitudinal? Those particular layers of muscle are going to contract in an alternating fashion, again, in the background, which is why this is going to involve what is called the myenteric plexus. A plexus, whenever you see the word plexus, you're thinking nerves. You all realize that? Last semester we had brachial plexus, cervical plexus. Remember those terms? Collection of nerves. But here you have a plexus of nerves that are in the what? What does mine refer to? Muscle. It's easiest to talk about a piece of intestines, but the same thing is going to happen in the stomach. The fact that you have these layers of muscle, they're going to alternate and they're going to cause movement. I do want to take at this particular point, and I guess I don't have it up there, but you see the letter M here for myenteric? I'm going to circle it. And I'm going to also tell you that the main type of action that you have with respect to the myenteric plexus is movement. And again, circle that first letter, which is M. Myenteric and movement. You have another plexus here. And that particular plexus, I don't have it up there. Let me just put this whole thing and put it down. You have a plexus in the submucosal. Do you know what the submucosa is? Underneath the what? Mucosa. So it's further toward the lumen. My enteric is further to the outside. This particular submucosal plexus is mainly going to be responsible for secretion. Do you see any consistency here? What?
Acid.
Acids, good. Use that as a key. Now, is there overlap? Absolutely. For example, if you can picture the myenteric plexus, the one that surrounds you on the outside, contracting, do you think it might squeeze anything on the inside and cause a little bit of secretion? Absolutely. So they're not mutually exclusive, but you can think of them, generally speaking, as their dominant area. No CNS involvement is critical. Gut-brain is what is often used to describe this particular control. It is controlled at the level of the gut. I don't know why they want to include the idea that it has to be a gut-brain rather than just gut control. But again, this is where the control is. It does not involve CNS. You see here the term muscularis externa. Have you ever heard that before? You know that muscularis externa is comprised of the inner circular and outer longitudinal. If we're talking about this particular contraction, which of these two plexes are we talking about?
Myenteric.
Myenteric, definitely. Long reflexes, the only difference there is that the CNS is going to be involved. In other words, you take information and you're going to involve something at higher levels. You don't have to have food in the GI tract. In fact, the example that I have up here is this particular thought. For example, Pavlov, have you ever heard of Pavlov? No. Thanksgiving is coming up. You're going to somebody's house. You walk in the front door and you smell everything. What do you think is going to happen?
You're going to salivate.
You're going to salivate. Okay? Now, you recognize that because it's in the oral cavity. But at the very same time, your stomach is producing enzymes and digestive juice. It's getting ready to receive that wonderful turkey or stuffing or whatever it is that is appealing to you. But it can work both ways. Walk by a garbage dump. You start salivating?
No. No. Got us from Thanksgiving to garbage.
I hope not. I hope not. But again, what I'm talking about is involving higher centers. This is not the level of the gut. Things higher up are going to control what is going to happen. Emotions can also affect it. If you're really, quote, tied up in knots, very depressed, you may not feel like eating, may not want to eat. There are other people who are stress eaters, so that when stress is introduced, they want to eat. Again, it's not something that's controlled within the GI tract itself. It's emotional eating. I'll even use that particular